The title of the presentation is Different Abnormalities of Electroencephalographic Markers in Quiet Wakefulness are related to visual hallucinations in patients with Parkinson's and Lewy body diseases. You see the contributors of this presentation and the affiliations. Beyond the diagnosis, we need biomarkers to follow the neurophysiological impairment in patients of Alzheimer's disease from preclinical to mild cognitive impairment and dementia stages, and also in the related dementias. A neurophysiological biomarker is the resting state EEG activity recorded in eyes closed condition, quiet wakefulness. You can see here a signal recorded from visual cortex in cats showing a dominant alpha rhythm around 10 Hz. Is the dominant rhythm also in human subjects. And the circuit generating these alpha rhythms is well known and involves corticothalamic, thalamocortical, and the interplay of GABAergic interneurons in the reticular thalamus. And also the modulation from cholinergic projection from basal forebrain. And Alzheimer's disease is a disorder of cholinergic system. So it's interesting the application of these procedures in the study of Alzheimer's disease. This is a complex EEG signal that you can record in cerebral cortex in the resting state condition. And you can decompose this signal into single oscillations from delta to beta and gamma rings. And you see that you can represent this single frequency power in the EEG power spectrum. Alpha rings is related to cortical inhibition in the cerebral cortex. In this study, we tested the hypothesis that resting state delta and alpha rings may characterize Alzheimer's disease, Parkinson's disease, and Lewy body disease at the group level from dementia to mild cognitive impairment. And that these abnormalities may be related to visual hallucinations. In this study, we compared EEG source activity in the resting state in normal elderly subjects in blue, Alzheimer's disease with dementia in red, Parkinson's disease with dementia in green, and dementia with Lewy body in violet. And we compared the sources in the frontal, central, parietal, occipital, temporal, and limbic regions for the frequencies from delta to gamma. You see that the dominant rhythm is in alpha frequencies and the maximum are in occipital areas in normal elderly subjects. And you can also see a really dramatic drop of alpha source activity in occipital areas in Alzheimer's disease patients with dementia. At the intermediate levels in Parkinson's disease with dementia and Lewy body disease with dementia. Also, you can see some abnormalities in delta rings. You see low levels of delta source activity in occipital areas in normal elderly subjects in blue, and a big increase in Parkinson's disease with dementia in green, and intermediate level in Alzheimer's disease and disease with Lewy bodies. The same picture could be observed also in Lewy body disease with mild cognitive impairment in the prodromal stage of dementia. And you can see the drop of alpha in Lewy body disease and a dramatic drop also in Alzheimer's disease with mild cognitive impairment in red. We could also observe an abnormal increase in delta RIMS in the parietal, temporal, and frontal areas in Lewy body disease with mild cognitive impairment, and also some increase in Alzheimer's disease with MCI. So a similar profile to dementia case. When we compare Parkinson's disease with mild cognitive impairment to normal subjects and Alzheimer's disease with MCI, we obtain very similar results. Even Parkinson's disease with mild cognitive impairment showed a decrease of alpha source activity in occipital and parietal areas when compared to normal subjects, but not so strong as Alzheimer's disease with mild cognitive impairment. And again, we could observe an abnormal increase of delta source activity in parietal areas in Parkinson's disease with mild cognitive impairment when compared to Alzheimer's disease and mild cognitive impairment normal subjects. This was true also in frontal areas. So we compared the Lewy body disease with cognitive deficits with and without visual hallucinations. You see in red and blue. And when we compare the source activities, we showed no big differences in alpha RIMS in Lewy body disease with and without visual hallucinations. In contrast, significant difference was observed in delta sources in the parietal regions. And you can see greater delta source activity in Lewy body disease with visual hallucination when compared to no visual hallucinations. When we compared Parkinson's disease with the cognitive deficits without visual hallucinations against Parkinson's disease with visual hallucinations, we observe differences in alpha but not delta. And so you can see here clearly that the differences between Parkinson's disease with and without visual hallucinations, red and green, are in alpha but not delta, in parietal, occipital, and temporal areas. So a difference with Lewy body disease with and without visual hallucinations. In conclusion, when we compare Alzheimer's disease with dementia and mild cognitive impairment with Parkinson's disease with dementia and mild cognitive impairment, we could observe a different profile of abnormalities of alpha source activity and delta source activity. And dementia with Lewy bodies was in the intermediate position. And so this could be interpreted as a nexus between Alzheimer's neuropathology and Lewy body neuropathology. And when we focus on visual hallucinations, we could observe that visual hallucinations were related to different abnormalities in the EEG, in dementia with Lewy bodies and Parkinson's disease, dementia with delta source abnormalities, and Parkinson's disease with alpha source abnormalities. These are our European projects supporting the research. Thanks a lot for your attention.